Hello students, today we are going to study the topic Uncertainty in Measurement of chapter Some Basic Concepts of Chemistry. When I am saying uncertainty in measurement, see in chemistry, what happens? You are calculating, doing the calculation in the experiment, in the lab also you are seeing how much the reading is coming. Okay, so whatever we are measuring, how much accurate it is, or how we can, big figures can be converted into a small figure, and so that it becomes convenient for us. For that we study what uncertainty in measurement in this chapter. Okay, so first is the scientific notation which comes under this topic. What do you mean by scientific notation? How does a big number can be represented in a small form? Okay, so formula for that is n into 10 to the power n. So here what does this represent? So for example, I am saying to you 232.508. It's a very big number, isn't it? 232.508 is a big number. So this can be represented in small form by, here you can see after, left to the point 32, I have brought it in the right hand side, and naturally the point shifts 2 points to the left hand side, and as the result we will write it as 10 to the power 2. Like that, another example I have taken 6023. Big number, isn't it, till 1000. Now if I want to make it more specific, what can I do? I can put up, if I put a point over here, what happens? It becomes 6.023 into 10 to the power. How much point after point it is coming? 0, 2, 3, 1, 2 and 3. So it becomes 10 to the power 3. Like that, any example you can take. Okay, for example, if you are taking any, like 165.2. okay, now for this how we will write? If we are shifting the point to the left hand side, it becomes 1.652 into 10 to the power 2, because you have taken this 2 over where? In the right hand side. So it becomes what? 10 to the power 2. So this is about the positive power of the 10. Now we will study about the negative power. See, negative power, it means a very small quantity. Okay, so here I have taken an example from the book only, 0.00016. Here what I have done, I have brought 1 to the right hand side. So our 0, this point has been shifted how many times? 1, 2, 3, 4. So it becomes what? 10 to the power minus 4. If we are doing addition of this scientific notation, so what happens over here? Here 6.65 into 10 to the power 4 we have taken, and we are adding 8.95 into 10 to the power 3. So here the powers you can see is different. So if the powers are different, addition becomes difficult. So what we do, we first of all we adjust the power. Okay, either what we will be doing, we will be adjusting 3 or we will be adjusting 4 over here. Here I am adjusting 3. So here what, if I am making here 10 to the power 4, naturally this 8 will be shifted to the right hand side of the point, and so it becomes what? 6.65 plus 0.895. This we will be adding. Our power is similar, so it will remain the same. So it becomes, when we are adding these two, we are getting what? 7.545 into 10 to the power 4. Now coming to the subtraction, this is also same as addition only. So here what we are doing, you can see over here, I have taken the figures 2.5 into 10 to the power minus 2 minus 4.8 into 10 to the power minus 3. Okay, so here here also we have to adjust the powers, otherwise it will be difficult to solve. Okay, so if it is either you have to make both minus 3 or both minus 2. Okay, here I have taken and I have made minus 2 both. So if I am making minus 2 over here, so naturally what happens, here 1 will be shifted in the right hand side, because here you can see it is in the minus. So minus में क्या होता है, what happened, the value becomes less. So here what happens, 2.5 plus 0.48 into what, 10 to the power minus 2. So we are minusing it and subtracting it. What we are getting, 2.02 into 10 to the power minus 2. Like multiplication, here multiplication, what do we do with the powers? We add the powers. Just remember that in multiplication we add the powers. So what we are doing, just taking out the figures and then the powers we are adding it, and then multiplying it, we are getting whatever figures we are getting, 3.864 into 10 to the power 14. How it is coming 10 to the power 14? Actually, when you will be multiplying it, you will be getting a bigger figure, because here 5 plus 8, it becomes how much? 13, isn't it? But if I am writing here, if it will be 10 to the power 13, so it will be what? 38.64 into 10 to the power 13. But if we are just changing it one place left to it, it becomes 10 to the power what? 14. Okay. Now likewise, if we are seeing in the negative sign also, here you can we are doing multiplication. Here it is minus 2, here it is minus 6. So we have to add minus 2 plus what? Minus 6. So if we are doing minus 2 plus minus 6, so it becomes what? 10 to the power minus 8, because plus into minus it becomes what? Minus. Okay. So here 9.8 into 2.5, here we are multiplying it, and when we are multiplying it, we are getting, so we are getting what? 24 point how much? Into 10 to the power minus 8. Or if we want to write, we can write 2.450 into what? 10 to the power minus 7. Okay, here actually it is in negative sign, so you have to remember that it will be decreasing if we are taking it to the what? Right hand side. Okay, now division, simple division is out there. Okay, like I have taken the figure 2.7 into 10 to the power minus 3 upon 5.5 into 10 to the power 4. Just we will be dividing 2.7 divided by 5.5. But what happens to these parts? We will be minusing it. How we will be minusing it? Numerator minus the denominator. Okay, so here it becomes what? 10 to the power minus 3, and here it is 10 to the power 4. So we will be minusing 4. So here it is basically what? Again I am doing it in this form. Here plus 4 has gone up, so it becomes we are minusing it, so it becomes minus only. So it becomes what? 3 and 4, it becomes what? Minus 3 and minus 4 becomes minus 7. So our value comes what? 0.4909 into 10 to the power minus 7. And yes, if we are taking it in the right hand side, taking it in the left hand side, sorry, okay, taking it in the left hand side, we are getting what? 4.909 into 10 to the power minus 8. Okay, I said to you, if you are going in the right hand side, the number will be what? Decreasing. If you are going in the left hand side, the number will be increasing. Okay, so this is all about the scientific notation under uncertainty in measurement. Rest will be studying right now the significant figures. So now the significant figures. Okay, what are significant figures? Significant figures are the meaningful digits which are known with certainty plus one which is estimated or it is uncertain. Suppose if we are writing like significant figures, it is saying that yes, one will be uncertain. To like if we are writing 9.32, okay, here 2 can be uncertain. Okay, so here if you are seeing two types of balance in chemistry. Okay, so here analytical balance and platform balance. This gives more accurately rather than the platform balance. Like analytical balance, if we are getting 8.521 okay grams, okay, here we are getting with the platform balance 8.5 grams. Okay, so here what happens in this 5 digit is what? Uncertain in nature. Always the value of analytical balance will be more than the platform balance. Okay, so here you can see there will be a difference of what, plus 1. Okay, so whatever reading we are writing, if it is 2 written over here, it might be plus 1 or minus 1 variation in this figure. Okay, and so this will be said what, uncertain in nature. Now rules, what are the rules which we follow for the significant figures are, all non-zero digits are significant. It means which is not zero, it is a significant digit. Like for example, if I have written 285, here how many significant digits will come? 3. Okay, here 0.25 non-zero digits count, so 1 and 2, so 2 significant digits over here. Now if we are talking about the second rule, 0 preceding to the first non-zero digit are non-significant. It means the preceding one which are coming before the non-zero digits are insignificant. So here these zeros becomes insignificant. So how many significant digit over here? Only 1, because this become insignificant, this also becomes insignificant. Now here if we are saying how many zeros, these zeros we will be not counting because it is non-significant. So how many digits are there total? Only 2. So 2 significant digits over here. Okay, so now next, coming to the next rule, 0 between 2 non-zero digits are significant. Okay, so it means this 0 which is coming over here is also significant because it is coming between 2 non-zero digits. So how many significant digits over here? 1, 2, 3, 4. Okay, come to the next rule. Okay, so here if I am saying zeros at the end, next rule, fourth, zeros at the end or the right of a number are significant, but they should be on the right side of the decimal point. Okay, so if they are saying these zeros, okay, are at the right side of the what? The decimal. So how many significant digits over here? It becomes how much? 3. Now, no decimal point, no significant figure. Like if I am saying 100, usually 100 is a big number for us, but here we are saying that it has got only one significant digit because here point is missing. Okay, like that if we are adding point and then we are writing 0, then it becomes 1, 2, 3, 4, so it becomes 4 significant digits. Okay, counting the numbers of the objects. Okay, like we say 1 dozen bananas or 12 bananas, okay, or 2 balls, or anything you can say which has can be just measured in terms of numbers. Okay, so here they are saying that counting of numbers can have infinite significant digits, because after 12 if you are going on adding, okay, here it is consisting of 4, if you add one more 0 it becomes how much? If you are adding one more 0, it becomes how much? 5 significant. So it is infinite. It depends how much zeros are coming after the point. So these are all the rules of what? Finding out the significant figures. So in case of scientific notation, when we are talking about the significant figure, all the figures are significant. Okay. For example, if I am taking 2.01 into 10 to the power 2. Okay, so here we will see the 3 are coming. So all of these, this is consisting of how much? 3 significant significant digits. Okay. So in case of scientific notation, all are significant whatsoever it is. 2 words I am talking here about: precision and accuracy. Okay, precision, when we are saying, it means we are precise, we are to the point. Accuracy means it is to the point. Okay, and here we are reaching to the point. Okay, suppose if the value of anything is 2 point, suppose if it is 2.5, okay, and if our reading is coming 3 or 2.6, so we are being precise to the reading. We can say that yes, we are coming to accurate to the reading what we have taken. Okay, here now how do we do the addition of the significant figures? Okay, for that I'm going to explain you with the help of example. I have taken three figures, okay, 12.11, 18.0, 1.012. So when we are adding this, we are getting how much? 31.122. But will we write this answer? If we are writing this answer, it will become wrong. We have to change it to the significant figure. If we are changing to the significant figure, we have to see after decimal to the right hand side how many digits are there. The least one we have to take. So here when we are seeing, here 2 is present, here 3 is present, and the least is 0. That is only one position. So when we will be writing the answer, it will become 31.1. Okay. Likewise, subtraction also we do in the same manner. Okay, suppose it is 12.11 minus 6.1. Okay, so you are getting the value how much? 6.01. The least value is of the one position only after decimal point. So its answer becomes 6.0. Now coming to the multiplication. When we are doing the multiplication, what happens? 2.5 into 1.25 I have taken for the example, and we are getting how much? 3.125. So we will not write 3.125. We have to see the figures in which the least number of significant digits are there. So here it is 2, here it is 3. So we have to take it this one and here. So we will write 3.1 only rather than writing 3.125. Now division, likewise we will be doing division also. Okay, so division mein what happens? 4.8444, big figure is there, divided by 2.4, we are getting something, the result 2.0185, but will we write the answer this? No, we also have to go to the least point only, so its answer becomes 2.0. Okay, so this is about the addition, subtraction, multiplication and division. Now how we will be rounding of the figures? Okay, so if for rounding of the figures, if it is 5, more than 5, suppose if we are having the figure 1, okay, here it is written, okay, 1.386. Okay, so if we want to round off the figure, here the figure becomes 1.39 because this is more than 5. Okay, now next we are taking 4.334. Here 4 is less than 5, so our figure becomes 4.33. Okay, likewise, suppose if it is more and if it is less, it is easy to write. But if our figure is 5 at the end, so what we are going to do? Suppose this figure only I am taking 1.385 it is. Okay, we have to round off this. So what we are going to do, this is an even number. Okay, so what you will do, you will not increase, it will be 1.38. Okay, now I am taking this 4.3345. Okay, so here 5 is there, here 3 is there, this is an odd number, so it will be increased, so it becomes 4.34. This is how we round off the figures. Okay, so this is all about the significant figures. Okay, this is all for today. Take care, students.